Y location, and then a byte indicating what type of thing to draw, and then 1 or 2 0 or 1 bytes of arguments for that, and then it uses that byte as an offset into a jump table and calls a function to draw something on the screen representing whatever it is. So there's a function for drawing hills and a function for drawing clouds. So it's that would be some more work, yes. I'm going to try and get back on the network right here real quick for the next thing. After this, which I hope will never end. Okay, finite state automata enemies. I promise you guys finite state automata enemies. Everything in the Boulder Dash universe is the enemies and the objects in there, which are subject to its little physics system, don't exist outside of the tiles on the screen memory. Every bit of intelligence contained in the enemies and all of the behaviors, all of the memory related to the state that the behaviors are in or what they're doing is contained in the tiles on the screen. So I've got this buffer of tiles that I iterate through, which is the same world that Mario exists in, and I go from the bottom of the screen up and from the left to the right on each of those rows, and I find out which tile is currently in the map. And well, you've seen the Firefly, you haven't seen the bullies in action. I think we're actually doing levels now, but that wasn't Cheese Grater. It's not that one. So yeah, the levels are ASCII text, which these get copied right into a two-dimensional array, just verbatim. Well, almost verbatim. So the W in there corresponds to the W that this thing's looking for there. Okay, fireflies. So the firefly likes to cruise around the edge of the thing, and then when it runs into certain things, it blows up. So, but there's actually 4 different icons that are the firefly. They look identical to each other. They all have the same piece of graphics, but there are 4 of them. One of them is, the first one is the one that's moving left. The second one is the one moving up and right and down. And the thing will continue in the direction it's going if it can. Well, first, if it runs into me, this code was actually jacked from some JavaScript. But if I'm up, down, left, or right of him, and then it explodes, which is recursive, you can set up some really impressive explosions in Boulder Dash. If you have rocks falling on fireflies, for example, because in the rock handling logic, it looks for fireflies or other things that are explodable. If it's empty and then it oh, well, the first thing that it does is it tries to turn left and then computes a new direction, which is left of its current direction. If the space to its left is empty, and then it turns left and goes there. Otherwise, if the direction that it's currently going, the space in the direction it's currently going is empty, and then it goes there. But when it goes somewhere, I'm replacing where it was with a space. I'm assigning a space in there. But which firefly goes there is computed from a table of which is left and what's right. So if I have a firefly that's going right and there's a space above it, it will turn into the firefly that's going up. And that's all the intelligence that it needs to continue circling around the edge of the level. All of the enemies in Super Mario Bros. 3 are similar. No, they're not similar. They're kind of similar. They're not entirely contained in memory, but each of them only has a byte or 2 of state data in addition to the location on the screen that keeps track of what they're doing. Is there a timer counting down before the Paragoomba starts flying again? Whatever. Is it heading towards you right now? Is it heading left or is it heading right? In each case, other things can act on it and it can change its state, or it can run into different conditions and change its own state. But the simulation of enemies is just a simple rules machine where you're currently executing one rule, and maybe under certain conditions you start executing other rules.
10 minutes.
Thank you. No love. I think I might have to get one of the home-built one of these. Die. Hey, let's look at some joystick opening code that doesn't work. Oh, of interest to the state machine, there's a table here of rather. The first two are concerned with Mario. I ripped out the 6502 that does the same thing and stuck this lookup in here instead. Rather, you can enter it from the bottom and sides, and rather you can enter it from the top solid, and then you land on it. Rounded affects how boulders roll off. Explodable means that if a firefly hits it, up. Consumable means it gets used up in an explosion. Sprite sheets. We'll talk about that in a minute too. So this always happens when I start writing Perl, but I've got 3,400 lines in one file. Happens when you don't keep your house tidy. I got this problem with this laptop. It's got a touch screen, so when it tries to open the first joystick, it's actually opening the touch screen. So I got this stupid little hack in there to try and work around that. Oh my god.
Don't die, man.
Don't scare me.
You got it to work.
This is what I really wanted to do. I didn't actually want to talk to you about games. I just wanted to sit here and play my hacked up Mario while you chatted on I don't know what.
Oh, you almost got it.
I made this level, I spent about 2 hours last night making this level easier and easier and easier. No, too late, way too late. Get it, get it, get it! Oh, oh, oh. No, well, what I want to do is, that's the exit. You can't see it very well, so if I can drop boulders on him while he's on top of the bricks there, I can blow a hole through the bricks and get to the exit. And also, that's not the ideal block to try and hit. And apparently I need the select button to restart the level, because right now Control-C is, I'm doomed, kill yourself. So, I hit the wrong one. I need to destroy boulders. Oops, oops. Well, that's one way to get to the exit.
You got 5 more minutes. You got 5 more left.
Oh, but that's gonna get me. Yeah, well,
Well,
Brock's levels are less obnoxious. I might have to.
people remember this is how you he kept playing more.
Dying was a fact of life.
They still have that with Super Game Boy.
I'd like to try that.
It's incredibly frustrating, but it's a great soundtrack.
So there are hundreds of Mario clones, but Kathik Cores was the only one that I saw for Perl. It gets away unless I really land on his head and get away. I think I'm being premature. I think I need to chill a bit. Oh, that's no good. All right, well, if we have some time left over, I'll come back to this.
About 3 minutes left.
In the finite state automata, rocks, if they're on top of something else that is marked rounded, they'll roll off the side. There's sand that... let's get some sand going. The sand works kind of like rock, except it spreads out more and it doesn't kill you when you land on it. And dirt itself, it finds the body of it, and if any part of the body of the dirt, if any of the connected or touching tiles are supported by anything that stays up there, the wood blocks, there has to be something piled up on one of the sides of them. So as long as there's something above or below, directly below left, below right, they will stay up. You can dig in the dirt. If I could take that out and manage to escape. But all of these different behaviors were just coded with keeping some state in and then a rock falls on me and die if I do that. Just keeping track of the state. The boulders go from a stationary boulder to a falling boulder. When they're stationary boulders, they don't kill you when you blow them. When they're a falling boulder, they do. They only turn into a falling boulder when they notice there's nothing below them. But they both of them have the same icon on the map, but there's actually two different things, and just that one bit of data, which boulder they are, encapsulates the dynamic part of their behavior. Simple finite state. Now, where did my presentation software go? Is that it? Oh, it's waiting for this. Okay. So yeah, that's the code. Good. Connected. Looks like it, but there's nothing there. Ship, I'm dead. The reason I answer my ship is I'm dead. Then when you die, you only see the asteroid that killed you. It takes too long to switch modes. I die before it. Okay, well, if you have a real X terminal, and you, oh God, I'm alive, help. Well, everything moves relative around me, so my main hope is, yeah. So you're probably familiar with the DEC VT100 or VT220 terminal.
What port is that?
Which what?
What port?
2003, slow SNet 2003. There's this company, Tektronix, that's known for their... Hey, that's kind of pretty. So while DEC was making these terminals that display text, Tektronix was making these terminals for graphing, for CAD, CAM, and visualizations, stats, whatever. It's a company that makes oscilloscopes. I'm going to die. Company that makes oscilloscopes. Oh, there's only one player in the game still. No one's telnetted to port 2003 on slowAss.net with a real X terminal. RxVT doesn't work. Mark Lehman cut this logic out. So yeah, Digital Electronics Corporation is making this thing displays text. They're making this thing displays graphics, but X terminal that comes with Unix has an emulation mode for Tektronix. Still only one player. Oh, okay. Then if you want to respawn, you have to disconnect with Control right bracket and then C, and that's the bullet that killed me. So with the Tektronix terminal, which the thing emulates, you can draw vector graphics over telnet and read mouse position. And it's this beast from the 70s. It's a fridge-ish. Okay, it's a large dorm fridge pedestal terminal. It doesn't have a computer in it. And Macs emulate this thing too. That's not SDL, but if you make vector games, if you make line drawing games, put them on the internet, and no one will play them. Not even if they're cooperative multiplayer. So Asteroid's sign is big. There's a few things that I do. One of them is random asteroids. I've got a radius that needs to be 360. Actually, this is just the draw routine. This is part of one of the methods where each object knows how to draw itself. But I start with the shape of the thing. The shape is interleaved in an arc, a length of distance along the outside of the thing, and a radius. So I'll have a large radius, and then I'll have an arc to a smaller radius, and then I'll have an arc to a larger radius, and then an arc to a smaller, and an arc to a larger, and I get this jaggedy-looking asteroid shape. And it's really easy to rotate because all I have to do when I start it is pre-add some to the arc. So I pick the arc. Well, I incrementally add the arc from picking up the shape, and then I pick the radius off, so I've got an arc and a radius. I compute my x and y from cosine and sine, feeding the arc into there. I have a two-dimensional rotated shape that I've rotated myself. Asteroids have a momentum for X and Y, and they also have momentum for spinning, and that momentum just gets added to the starting arc each time. This is computing the random shape of the asteroids. I have a flip-flop that goes back and forth between 0 and 1, and I use one of two different little expressions for picking a random number depending upon it. One of them tends to generate larger, the other tends to generate smaller. I keep a tally of the total radius. When it's over 360, I add whatever's left and stop drawing. And I have an arc that tends to kind of a, what do you call it? Just a bump in distribution. And I just keep adding those, the alternative radius and arc to the thing until I'm done. When I animate stuff in this universe, the velocities are random, but they're computed when you bust something, otherwise they're random to start with. So I just add my velocity to the x and y. I promised you gravity too, but you're not going to get that unless I pick it out of Super Mario code. My rotation, I have a rotation velocity, I just add that in, and that, again, affects where I start drawing the thing. My ship is one of these shapes, too. It's not randomly drawn, it's hard-coded. My nose is 10 pixels out. The top of the back fin is 8 pixels out, and then 3 pixels for the back, and then 8 for the other back fin, and then back around to the nose again. So I've got an arc of 140 degrees between the nose and the back fin, and arc of 40 degrees to the back, and so on and so forth. The same function that draws the asteroids draws the ship. When an asteroid breaks up, I take a random angle and I initialize my velocity from the both of these projects, by the way, TechRots and the Mario clone are both in gists on GitHub. As all of my projects are in gists. They might as well, because I just put all my code in one big file that goes on forever. Is it?
Yeah.
Oh, okay.
Yeah, sorry.
Yeah, I kind of figured, but I don't think you actually told me.
Oh.
Adding thrust, similarly, we're just kind of separating out the X and Y parts and tallying them up. Oh, collision detection. We didn't talk about this at all. Shit. Okay, you guys got ripped off. Okay, well, code games. Do it for the lulz. Thank you for your attention.
Love you all.